Hi, welcome back. Let's continue with chapter 4.3, orbital overlap and hybridization. In 4.3a, we have to roughly understand what is the difference between sigma and also pi bond, how the bond can be formed through the overlapping diagram. Okay, let's look at the relation between covalent bond and also the orbital overlap. In the previous chapter, we learned about how to draw Lewis structure, and then we also apply the VSEPR theory to determine the shape of an molecule. But then in this theory does not explain how the chemical bond is formed. So if we want to know how the bond is formed, we are based on the valence bond theory. So according to this theory, covalent bond is formed when the orbitals are overlapped. So in the overlapping region, they will have a pair of electrons. And then the share region, basically we will mention that it is orbital overlapping. So there are two electrons in the opposite spin in one orbital overlap, which is similar with what we know. One orbital maximum only can fill 2 electrons, and both 2 electrons must be with the different spin. Proceed to tutorial question number 1. Describe the formation of sigma and also pi bond. So this is the symbol for sigma bond and this is the symbol for pi bond. So generally, how a sigma bond can be formed when the orbitals are overlapped end to end. Okay, while for the pi bond, the orbital will overlap sideways. So focus on the diagram 1 here. So a sphere or s orbital with the sphere shape, they overlap between with another s orbital. So this overlapping area we know it as orbital overlapping. And inside this orbital overlapping, there are 2 electrons with different spin. Okay, because of the orbital are overlapped end to end, so this bond will known as sigma. Similar case for the hydrogen fluoride. Hydrogen have 1 electron, phosphorus has 7 electrons, but when we look at the 2s and 2p, fluorine have 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. So the one of the 2p orbital is only have 1 electron. So that's why they are unstable. And then hydrogen only have 1 electron. So both orbital which have 1 electron, if they overlap, they will able to have 2 electrons with different spin. So again, because of the orbital is overlapped end to end, so this is sigma bond. While for another one, you will notice that the 2p orbital is overlapped side by side. So if this case happen, we say that they overlap sideways, and then still the same, there are 2 electrons with different spin. Okay, but then this, because of different way of overlapping, so the name of the bond is considered of pi bond. And pi bond always occur in multiple bond. Tutorial question number 1b. First, we have to draw the Lewis structure for benzene. And then we are going to label sigma and also pi bond. So this is the Lewis structure for the benzene. Benzene has a hexagon shape, so each here is the carbon basically, and then the formula for benzene is C6H6. So each carbon has 4 bonds. So from here you can check each carbon has 4 bonds. Okay, while for the hydrogen always have 1 bond. So this Lewis structure for the benzene is correct. So then to keep in mind, first bond between 2 atoms will be considered as sigma bond. So this carbon 1 and hydrogen 1. Between these two bonds, first bond is sigma bond. So, and then let's say we have carbon 1 with carbon 2. Okay, these two carbons are different, right? So means that, but they have two bonds. So one is sigma and then another one will be pi bond. So you want to label which one as sigma or pi is okay, because from here we cannot see how the orbital overlap. Okay, so normally because of we mentioned that just now, first bond is the sigma bond. So at the top here we normally will label as sigma. So and then C2 and H2 is another two atoms again. So between these two atoms, the bond, first bond is sigma bond. Okay, similar case for this carbon 3 with the hydrogen 3, first bond is sigma, but carbon 3 and carbon 4, first bond is sigma, second bond will be pi bond. The bond between carbon 4 and so-called hydrogen 4 here is sigma. C4 and C5, fifth carbon and fourth carbon, first bond is sigma. Carbon 5 and and hydrogen 5, between here, first bond sigma. Carbon 5 and carbon 6, first bond is sigma, second bond will be pi bond, while carbon 6 and hydrogen 6, the first bond is sigma. So basically, all the multiple bond will be considered as pi bond. Okay, this is what we already mentioned in the previous slide. Tutorial question number 2a. What is the meaning of hybridization for the atomic orbital? So this is a process at where we are going to mix a number of atomic orbitals, minimum 2 and maximum 6 orbitals. Okay, to form same number of new and identical set of orbital, which we will know them as hybrid orbital. Okay, so means that if you mix two orbitals, after that you are going to get back two orbital, and these two orbital now will be new, different from the before mixing, and both of them are same. Next, after we get the idea of the hybridization, generally for sure, when we want to answer the question, we are going to identify the type of hybridization. Okay, when we want to know the type of hybridization, basically we need to know the number of electron group or electron domain at the central atom. So generally, before you can determine the number of electron group, means that you have to draw the Lewis structure. Based on the Lewis structure, we will able to determine the number of electron domain at the central atom. And then based on this number, then we able to determine the type of hybridization. Okay, because of just now we mentioned that we can minimum mix 2 orbital, maximum mix 6 orbital. So we are going to have check with the Lewis structure. You may have 2 electron domain. If you only have 2 electron domain, then the type of hybridization is sp, means that you are going to involve one s orbital and also one p orbital. So if you only have 2 electron group, basically again we are going to know that in the orbitals they will contain electrons. So according to VSEPR theory, electrons will going to arrange themselves as far as possible. So when you have 2 electron domain, so the best arrangement will be linear. So if you have 3 electron domain, means that basically we need 3 orbitals. One is s orbital and then another 2 is p orbital. And so on until 6 electron domain, means that we're going to mix with 1 s orbital, 3 p orbital and 2 d orbital, which total have 6 orbital, and the type of hybridization will become sp3d2. Why we doesn't have s2p? Because there is only one s orbital in the valence shell. So same case to the p orbital, maximum only have 3. So that's why we didn't have sp4. We can have sp3b. Proceed to tutorial question number 2b. Name the type of hybridization of the carbon. In this question, they are very specific. They want carbon. So for example, CH3COOH. So we need to know what is the type of hybridization for this carbon 1 and also this carbon 2. Okay, before again, like just now we say, before we can determine the hybridization, we need to know the number of electron domain or electron group. So before we can know number of electron domain, means that we have to draw the Lewis structure. Okay, so then maybe you can keep in mind that carbon always has 4 bonds, while nitrogen always has 3 bonds, oxygen 2 bonds, while hydrogen 1 bond. Okay, in this case, we are not going to draw the Lewis structure as 4.1 because in the 4.1, generally the step given is only consists of 1 central atom. So in this case, like question number 1, both 2 carbon will be considered as central atom. And for number 2, CH3, this carbon is central atom, CH also central atom, and then this also central atom. So in this case, we can see all the carbon which underlie basically is considered as central atom. And then each compound here or each molecule here has more than 1 central atom. So it is not advised to use the method that we learned in 4.1 because it will take more time compared to apply these simple tips. Okay, now let's based on these tips, we try to draw the Lewis structure for CH3COOH. As we know just now we say carbon always have 4 bonds. So 3 bonds are bonded to the hydrogen. And then the 4th bond will bonded to this carbon. And then for carbon, they are going bonded to oxygen. And then oxygen will bonded to hydrogen. So in this case, this is the Lewis structure for CH3COOH. Okay, you can check at here, this carbon, all the hydrogen, very obvious, only contain 1 bond. And then now we have 2 carbon here. So all these 2 carbon have 4 bonds, while for the oxygen, always have 2 bonds. So which is fulfilled here. So basically, don't forget, actually, once the oxygen have 2 bonds, they also going to have 2 lone pair electrons. So same case happen to the oxygen here. So now we want to determine the type of hybridization for this carbon. Okay, let's say we label this carbon 1. So carbon 1 basically have 4 electron domain. Okay, because have 4 single bond. So if they have 4 electron domain, so based on previous slide, the type of hybridization is sp3, where they need 4 orbitals, which make up from 1 s orbital and also 3 p orbitals. While for the carbon number 2 here, we consider this carbon 2 has 3 electron domain. Okay, you still remember that double bond, triple bond also considered as 1 electron domain. So have 2 single bond and 1 triple bond, 1 double bond. So altogether is 3 electron domain. So 3 electron domain means that we're going to mix 1 s orbital and also 2 p orbital. So the type of hybridization is sp2. Question number B2, CH3, CH double bond CH2. So again, we roughly already have idea. Carbon have 3 bonds, which are bonded to the hydrogen. And then second carbon will bonded to hydrogen. And then double bond with carbon. And then last carbon have 2 hydrogen. So when we check at here, carbon 1 have 4 bonds. Carbon 2 also have 4 bonds. Carbon 3 also have 4 bonds. So you will notice that carbon 1 has 4 electron domain. So that's why the type of hybridization is sp3. While for carbon 2 have 2 single bond and 1 double bond, so sp2. Similar case happen to the carbon 3, so that's why we also will have to mix with 1s orbital and also 2p orbital. Therefore, the type of hybridization is sp2. Question B3, CH3, CHO. So basically, I think you all already have an idea. If CH3, it will roughly look like this. And then continue with carbon, bonded with hydrogen, and also with oxygen. So again, if you put oxygen here, only single bond, then you will notice this carbon have 3 bonds, while oxygen have 1 bond. But according to the tips here, carbons always have 4 bonds and oxygen have 2 bonds. So that's why we say oxygen always 2 bonds. So make it double bond, and then we'll have 2 lone pair electron. So in this case, carbon 1 consists of 4 electron domain. So the type of hybridization is sp2. While carbon 2 has 3 electron domain, which are 2 single and 1 lone pair. So the type of hybridization is sp2. Last question for the B4 is HC triple bond C CH3. So based on here, I think we roughly can have the idea. Hydrogen connected to carbon, and then this carbon will have triple bond to another carbon. And then this carbon connected to carbon again, and the carbon connected to 3 hydrogen. So again, based on the structure here, you will notice that hydrogen always have 1 bond, while carbon always have 4 bonds. So this is carbon 1. We consider this carbon 1 have 2 electron domain, 1 single bond and 1 triple bond. So that's why the type of hybridization is sp. Similar case happen to the C2, also 1 triple and also 1 single bond. So the type of hybridization is sp. While the last carbon, carbon 3, have 4 single bond. So that's why the type of hybridization is sp3. Proceed with question number 3. Determine the type of hybridization for the underlying atoms. So basically, you will notice all the underlying atoms are central atom, or you also either notice they are the first element in the chemical formula. But do remind that hydrogen and halogen never as the central atom. So before we can determine the type of hybridization, again, first we need to draw the Lewis structure, followed by determine the number of electron domain. Based on the number of electron domain, then you will be able to know the type of hybridization. Okay, so now let's start draw the Lewis structure for BF3. Boron has 3 valence electron, fluorine has 7. So all together is 24 valence electron. Boron is the central atom. So basically, I will already have the idea. Have 3 fluorine. Each fluorine have going to achieve octet. So 8 times 3 equal to 24. So there is no extra electron. So this is the Lewis structure for BF3. So according to here, boron are surrounded by 3 electron domain. So the type of hybridization is sp2. Question B, we have CCl4, and where we know carbon have 4 valence electron, chlorine has 7 valence electron, times 4, so total is 32 valence electron. Okay, so end up here, each chlorine have achieved octet, have 4, so 4 times 8, 32. Again, there is no extra valence electron. So this carbon have 4 electron domain. Hence, the type of hybridization is sp3. Question number C. Phosphorus has 5 valence electron. Chlorine again has 7. And then negatively charged means we are going to gain 1 electron. So total here is 48 valence electron. So as we based on the chemical formula given, there are 6 terminal atom. Each terminal atom basically is going to have 8 electrons. So 8 times 6 total is 48. So means that there are no extra electrons. So that's why I roughly will have the idea that the PCl6 negative is going to look like this. Okay, so I didn't draw all the valence electron at the terminal atom because for this question we just want to determine the type of hybridization. So based on here, it's very obvious that there are 6 electron domain, and the type of hybridization will be going to be sp3d2. Continue with question D. Sulfur 6 valence electron, fluorine 7 valence electron, total 28 plus 6 is 34 valence electron. Based on the formula here, we know there are 4 terminal atoms. Each terminal atom is going to 8 valence electron. So we are going to -2. And then here we will notice that there are extra 2 electrons, which will going to become lone pair electron. So at here, then we are going to know that there are 4 terminal atoms plus 1 lone pair electron. So we're going to have 5 electron domain. And the type of hybridization will be sp3d2. E. Nitrogen have 5 valence electron. Hydrogen have 1 times 4, so have 4. Positively charged means that the compound going to lost 1 electron. So means that total are going to have 8 electron. So then here we have 4 terminal atom, and this time the terminal atom is hydrogen. And we already know that hydrogen maximum always 2 electrons. So for hydrogen minus means that consists of 8 electrons. So after we minus, there is no extra electron. So we know that there are 4 terminal atoms with single bond. So that's why I have 4 electron domain. And the type of hybridization will be sp3. Last question under question number 3, H2S. So in this case, sulfur is the central atom because hydrogen never be the central atom. Hydrogen have 1 electron, but we have 2 hydrogen here. And then sulfur have 6 valence electron, so altogether is 8 electron. But based on, again, the formula here, we have 2 terminal atoms. So means that hydrogen always achieve triplet, so means that we are going to -4. So these 4 extra electrons will going to form 2 lone pair electrons. So then the 2 lone pair electrons we plus with 2 terminal atoms means that going to have 4 electron domain. So if there are 4 electron domain, so the type of hybridization will be sp3. Okay, this is the final answer for the tutorial question number 1B, 2B, and also 3B. So in next video, we are going to discuss about the hybridization process. Thank you for watching this video. See you.